Lesson 32, Trigonometric Ratios. Okay, so if we do a little bit of review on this concept, so sine theta was just equal to the opposite over hypotenuse, right? This is just SOHCAHTOA, right? But in terms of our unit circle, we could say sine theta is equal to our y value, right? Our y value, which is the opposite, divided by our hypotenuse, which is our r value, right? So y over r, right? And on a unit circle, this gets a little bit easier because then y, it would just become y over, and then a unit, right? Because we're saying that our length of our radius here, or our terminal arm, is just going to be 1 on the unit circle. Okay? So then sine theta is really just equal to y, right? So like y is equal to sine theta. All right. Similarly with cos, we can say, well, that's the same thing as x over r. Okay, well, that's the same thing as x over 1, right? So you can say x is equal to cosine theta. This is all a review from last lesson there, right? Now, for tan theta, that was y over x, so that would be sine over cos, right? Y is sine and x is cos, so that'd be the same thing as just saying sine theta over cos theta. All right, so now that we know that, let's start looking at our reciprocal trigonometric ratios. So you guys have seen these on your calculator probably. And what they are is, well, what I was just saying there, the reciprocal. So this is pronounced secant. Okay, secant theta is equal to 1 over cos theta, right? So reciprocal means like flipped upside down again, right? So you can also think about it, if it's 1 over cos theta, that would be the same thing as now, instead of, so remember cos theta was equal to x over r. So the reciprocal would be r over x, right? Those things are flipped. So 1 over cos, and then what those are equal to is flipped as well, right? Cosecant theta, so CSC theta, is equal to 1 over sine theta, which would be the same thing as now flipping those two as r over y, or 1 over y, because it's a unit circle. And then the last one is cotangent. Okay, cotan theta is equal to 1 over tan theta. Now, we'll have to work on memorizing these and like how they're related, right? Because quite often, myself included when I was learning this, I remember, I always thought that these were kind of backwards, right? Secant, I always thought should have went with sine, not cosine, right? So, and that's just because they start with like opposite letters. So cosecant goes with cos, or sorry, secant, goes with cos, and then cosecant goes with sine. So you might have to remember that those things are like maybe the opposite of what you think they should be. You can't just go by like the starting letter, right? Because those are actually opposite. Okay, so however you got to memorize those or remember them, just try not to make that mistake. All right, so let's do a couple. It says determine the value of secant of 200 degrees. Well, to tell you the truth, on a lot of your calculators, you guys probably could just put it in as secant 200 degrees. You guys would have that option. But if you didn't have that option, we could use, well, what we know secant is, right? Secant is the same thing as 1 over cosine theta. And if this was on our unit circle, we could pull out the unit circle and figure out the exact value. But we don't. So what we're going to have to do is actually just plug it into our calculator. So we're going to write this instead as 1 over cos of 200 degrees. Okay, because that's what secant is. Okay, and if you put that in, you would end up getting negative 1.0642. Okay, and then the next one, term the value of cotan, and then negative 3 pi over 5. So this one you might be thinking, okay, that's got to be on the unit circle, right? But just if you check out your unit circle quick, and I'm sure you guys all have it memorized by now, right? None of these angles in radians are over 5, right? None of them. It goes 3, 4, 6. So this isn't on our unit circle, right? So same thing. All we're left with is just to be able to plug it in. So all we can do here is just rewrite this as 1 over tan of negative 3 pi over 5. And then just plug it in, and then you would end up getting 0.3249. All right, Now, this part, it's kind of like, I don't know, it's a little needlessly confusing. Tell you the truth, I think we're going to take this part out in future notes. So if we want, let's skip through those ones and let's jump into this. All right, so determine trigonometry ratios from a point. So we've actually done this in 20-1. So this should be review, but I'm sure it seems like a long time ago now. All right. So to do this, we're going to utilize Pythagorean Theorem and then just some of these ideas that we've just talked about above, right? All right, so to get our bearings here, it says the point Q, which is at -9, 6, lies on the terminal arm of a rotation angle theta in standard position. Solve for the exact values of the primary and reciprocal trigonometry ratios for angle theta. All right, so what does all that mean? Okay, so what we're saying here is that if we drew our Cartesian plane, then we would add a point at -9 and 6. So maybe somewhere like that, right? So here, we'll get some different colors going here too. Okay, so it's somewhere there. So we'd say this is at -9, 6. All right, so what does that mean now? Well, that's an x value there, right? And that's a y value. So it's going to be a lot more useful, I think, if we actually rewrite this as a triangle, as a right angle triangle. Okay, so what would our x value be, or the black part of that? Well, that would be -9, right? That's our x value. And then our y value, well, that would be 6. Okay, so then trigonometric ratios, right? When I'm saying trigonometric ratios, really what I'm talking about here is Sohcahtoa, right? You guys have seen that before, Sohcahtoa. So then, all right, opposite, adjacent, right? So I have my opposite and adjacent. The only thing I'm really missing here is my hypotenuse. And if I did, then I can just kind of go to town doing all my primary trigonometric ratios. And then even the reciprocal, all I got to do is just flip those things around, right? So that's actually not much more difficult. But the thing in our way is really just figuring out what our hypotenuse is there, right? So let's solve for that. So here, so this would be our y, right? And that would be our x. So let's write it out the proper way here. So this would be r squared, right? Because this would be our r. Okay, so we'll say r squared is equal to x squared plus y squared, right? Instead of a, b, and c, right? So this would be r is equal to the square root of -9 squared plus 6 squared. So your r would be, and then we just have to leave it like this. This would be the square root of 117. All right, so now that we have that, the rest of it's actually pretty straightforward, because if we're looking at Sohcahtoa, right, or, we're looking at sine theta is equal to, well, remember that was just y over r, which is really opposite over hypotenuse, isn't it? Y over r. So then that would be, so sine theta would be equal to, well, we know that y was 6 and r was square root of 117. Okay, now technically we would want to rationalize this, right? We don't like having square roots on the bottom. So we would multiply by 117 on the top and the bottom. So technically this thing should have been equal to 6 times root 117 over 117, right? But you know what? Quite often when we're doing this quick, I might just leave it like that. So I'll leave the other ones like that. Okay, so that's sine. So let's do cos. So cosine theta is equal to x over r. Okay, so cosine theta is equal to, and our x was -9. So -9 over square root 117. Tan theta is equal to y over x. So tan theta would be equal to, our y was, what was our y? 6 over negative 9. Okay, which is equal to negative 2 over 3 for tan theta. All right, so we got 3 of them. We just need the other ones now. Okay, so here, I'm just going to clean this up a little bit. So now we got to find the reciprocals of these, right? So we got to find our reciprocal trig ratios. So that's that cosecant, secant, and cotangent. So this is like bizarro world sine theta. So in this one, the reciprocal of sine is cosecant, right? So that's going to be equal to, well, just really those two flipped around, right? Because it was really r over y. So that's just going to be square root of 117 over 6. So that's easy. And then cos theta, so this is secant theta, is the reciprocal of that. So that would be negative square root 117 over 9. And then tan is cotan. So cotan theta is equal to negative 3 over 2. Okay, next part. So that was finding it using a point. So now it's going to be similar. Now we're going to solve it from a trig ratio, right? So you're given one of these trig ratios, and we have to find the others. Okay, so let's jump into to an example. So it says determine the value of the other 5 trig ratios if secant theta is equal to negative 5 over 3. But then they've also given us some restrictions here, right? They say where theta is greater than 0 but less than pi. So let's sketch this out and see if we can make sense of this. So we've got secant theta is equal to negative 5 over 3. All right, so looking at secant here, really what I want to do is I want to figure out, you know, if the 5 or the 3, like what values those would be, right? Like, is that my r value, my x value, my y value, like for the 5 and the 3? So to get our bearings here, let's just remind ourselves. So secant, the reciprocal of that was cos, right? So cos theta was equal to, well, it was adjacent over hypotenuse, right? Which is the other way of putting that is x over r. All right, so if I'm looking at this, right? This is really saying r over x. So the 5 is my r and the 3 is my x. Okay? Now, whenever we're doing these things, it's never the r value that's going to have the negative attached to it, right? So this would really be, you know, secant theta is equal to 5 over negative 3. Okay, so the negative had to be attached to one of them, but it's never going to be the r value, right? Because the r value is really just your terminal arm. That's not going to be negative or positive, right? It's only going to be negative or positive if you're like in the x direction there or in the y direction there. Okay, so the negative is attached to the x there. So sorry, let's go. That was our r and that was our x, right? So now we can kind of sketch that out, can't we? So this thing should have, you know, an x value negative 3. Right, so we use a different one there. So let's go. Okay, so this would be like negative 3, right? And then an r value would be 5, right? So this could actually be 2 different places, right? This could be here, right, going up there, and then having like a y there. Or it could be down here as well, and having the negative y, right? Because all we know is that that purple one there, the x, is negative 3, and the r is 5, right? So that'd be there and there. And we don't really know which one we're talking about, right? There's actually 2 different ones that we could be meaning here. Now, while I'm on that train of thought, right, like I figured that out by kind of sketching it out. The other way we could have done this, right, was by using our cast rule. Okay, so I know this was secant, right? But secant is just the reciprocal of cos. So anywhere that cos is positive or negative for our ratio, secant will as well, right? So if I know this is a negative value for secant or negative for cos as well, then I'm going to look at here and say, okay, where is cos negative? Well, cos is negative here, and it's negative here, right? It's negative in quadrant 2 and quadrant 3. Well, that's exactly what we have over here for the reason I showed you with the negative 3 coming over, right? All right, so hopefully that made sense. But right off the bat, you could have just wrote out cast and then put your two lines out there, like just kind of quick and easy, right? Okay, so if that's the case, let's figure out now the next step here. So now that we have that written out, well, we would use Pythagorean Theorem to solve for the green side there, to solve for our y, but which one, right? We actually have two different ones to deal with. So we would have to solve for them both? Well, not really, because they actually gave us a restriction, right? That said, we're only actually concerned from 0 degrees to pi, or zero radians to pi radians, right? So 0 would be over here, and then pi would be over here. Okay, so it would be from there to there. So that means I don't care about down here. Okay, so that's why the restrictions kind of helped us out. Now I know I'm just talking about quadrant 2. Okay, so now that I know that, now I'm just going to focus on this triangle here, right? This top triangle. So let's use Pythagorean Theorem. So this would just be y is equal to the square root of 5 squared minus negative 3 squared. Okay, so now technically this would be y is equal to plus or minus 4, right? Well, that plus or minus 4, well, that makes sense, right? Because it could have been minus 4, or it could have been plus 4. But we know we don't actually care about the minus 4, so this is really just y is equal to positive 4. Okay? So there, now we have all the sides, right? It's just a 3, 4, 5 triangle, so we can just go to town writing all of our trig ratios now. Alright, so that would just be, okay, we'll do, well, they gave us the first one, we'll write that again. So we have secant theta, we know is negative 5 over 3. So then let's just do the opposite of that one right off the bat, right? So that's one of them. The opposite of secant is cos, so I know cosine theta would just be those two guys flipped around. So negative 3 over 5. Okay, and then we'll do sine. Yeah, we'll do sine theta. Maybe I'll do them down here to keep them in order here. So sine theta is equal to, so sine would be 4 over 5, right? 4 over 5. Opposite over hypotenuse, right? 4 over 5, or y over r. Okay, so that would make cosecant theta just the inverse of those. So that'd be 5 over 4. Okay, and then tangent theta is equal to, so tan is opposite over adjacent, or y over x, so that's 4 over negative 3. So negative 4 over 3. And then cotan theta would just be negative 3 over 4. All right, so let's do the next one. All right, so let's look at this next one. So first off, we're going to have to change something in your notes here. Can you guys change this to, instead of secant b is equal to root 7 over 3, as secant b is equal to root 12 over 3. This one actually didn't work. When you do it, you end up getting the square root of a negative when you solve for one of the sides there. So okay, so just change it to that for me if you haven't already. Maybe if you have the newer notes, it already is. Okay, so looking at this one, it'll be similar to above. So let's kind of get our bearings here, right? So again, we could just use our cast rule, to figure out what we're looking at here. So cast, right? So cast is telling you where these ratios are positive, right? So secant is really the same, or it's going to be negative and positive. It's the same as cos, right? Like cos is the opposite of secant, or the reciprocal. So where is cos positive? Well, cos is positive here and here, in those two. And that makes sense, right? Because cos is usually x over r, right? But this is going to be r over x. Okay, so this means that if we sketch this thing out, our x value would be 3, right? X value would be 3, and our r value would be root 12. root 12. Oop. Okay, there and there. So root 12. Okay, so that makes sense then, right? Positive 3 would make it in both of these quadrants, right? So, all right, let's make our y values green there. So, yeah, if we want to find cotangent and cosecant, then really we just need to solve for y here. But do you guys see how this is different than the last one? The last one, they gave us a restriction, and it ended up canceling one of those, right? So we were only dealing with one triangle. That's okay. Now we just have both, right? So we're going to have the positive and the negative version of y that we're going to have to write out, right? So there'll be two answers for cotangent and cosecant. Okay? So let's solve for y. So that would be, well, let's write out r squared is equal to x squared plus y squared. So y is equal to the square root of r squared minus x squared. So y is equal to the square root of, and then our r was root 12 squared minus, and then x was 3 squared. Okay, so r is equal to the square root of 12 minus 9. So y is equal to the square root of 3. Okay, and technically though, it wouldn't be just the square root of 3. Whenever you take the square root, remember there's the positive and the negative version of that, which actually makes sense in our case, doesn't it? Because we want a positive and a negative version of this. All right, so we're pretty good to go. So this would be, all right, so this would be root 3, and this would be negative root 3. All right, so now we just put it all together. So cotangent B would be equal to, so the opposite of tangent, right? Tangent was y over x, so this is x over y. So this is going to be 3 over root 3. And it'll be equal to negative. You know what, though? Let's do it with the positive version. And I'm just going to rationalize this denominator first. And then we know we're going to have like the positive and negative version of that, right? So, all right, so we're going to multiply the bottom and the top by root 3 just to get that square root out of the bottom, right? So now this is equal to 3 root 3 over 3, right? Root 3 times root 3 was just 3, so those cancel. So that's just the same as root 3. Okay, so then there's my one answer. So cotangent B is equal to root 3. But then it was also, just remember, like the other version of this was just dividing by negative root 3, okay? So our answer here is just going to be like plus or minus root 3, right? Both of those. All right, so now let's move on to cosecant. So cosecant B is equal to, so cosecant is the opposite of sine, right? And sine is y over r. So this will be r over y. So that'll be root 12 over y, so root 3. Now, one thing we're going to want to do with this root 12, though, is write that in simplest form, right? So root 12, right? I can rewrite 12 as 4 times 3, right? And then now that I've done that, I can take the 4 out as a 2, right? I can take the square root of that. So that would be the same thing as 2 root 3. Okay, so we should have it written like that. So that would be 2 root 3, and then over root 3. So hey, look at that. We don't even need to rationalize anything because those root 3's are going to cancel nicely. So that's just equal to 2. But then technically, right, because we were dividing by, no, it would have been positive root 3 and negative root 3. So if this was like negative root 3, then, you know, our answer in the end, we would divide by a negative. So this would be plus or minus 2. So cosecant B is just equal to plus or minus 2. Okay, last one. So now if cotan theta is equal to negative 5 over 9, determine the value of cosine theta if our domain is restricted to pi over 2 to pi. Okay, so pi over 2 to pi. All right, so what does that mean first off, right? Between pi over 2 and pi, that means it has to be greater than, remember this is pi over 2 there, and that's pi there. So I'm in here. Okay? So, all right. We could use cast rule if we like again, right? Cotan would be the same as tan. So if we did the cast rule, then where is tan negative? Well, tan is negative here and here. All right, because the cast rule tells you where it's positive, so it's negative in the other ones. All right, so that means this one, right? We're not worrying about that one, right? Because we have these restrictions. And let's just make sure that makes sense too, right? With that cast rule. So tan is y over x, so this is x over y. So it could either be that our x is negative here, right? This would be like negative 5. Okay, so that'd be like negative 5, and this would be 9. Or the other option is it could have been positive 5 and negative 9, right? So that's why it works out in both those quadrants, right? But like I said, you can use the cast rule too, but now we know we're talking about this one, okay? All right, so if that's the case, then we can make our little triangle here. We know that this is negative 9 or negative 5. This is 9. We really just need our hypotenuse, or r. Okay, so we'll just solve for that. So r is equal to the square root of negative 5 squared plus 9 squared. So r is equal to the square root of 106. So then we're pretty good now, right? We have all three. So now we can say, okay, well, cosine theta, cos is just equal to x over r. So that's just going to be negative 5 over square root of 106. And then let's rationalize that. So that'd be square root of 106 on the top and bottom. So that would be negative 5 root 106 over 106.